Now we are going to see about the types of set. Okay, in exercise 1.2 we are going to see about the types of the sets. Okay, the first set is a empty set or null set or void set. Okay, it is also called as a empty, null set or void set. Okay, mostly they are using empty set or null set alone. Okay, so the empty set is we can written like this or this. Okay, empty set is like this or this. Okay, this is a symbol for the empty set. Okay, so inside the bracket if you write this means it's wrong. Empty set means once this pi or this empty bracket. Okay, this is a empty set. So for example, in your book they given what they given a equal to x such that x is an odd integer. It's divisible by 2. Okay, if a odd number means it can be divisible by 2, so it's not a possible, right? So that's why I am having a empty. It's not having a some value, it's not having a value, so that's why I write open means this bracket or this. Okay, then the set of all integers between 1 and 2. So what they mention, the integers, the number integers is -1, 0, 1, 2, 3, etc. like that only. So we know the numbers only, we can write the counting wise. Okay, if I am having the next number is 2, next number is 3, in between number we don't know, right, in a integer, so that's why it's a empty. Okay, the next one is a singleton. Single means we already know the only one value. Single means I am a single person, means I am a only person. Nisha means single means I am a single. Nisha is a single, like that only. Okay, if I am having a set A equal to this means I am having a single number, right? So this is a single set, that's it. Okay, so for example they given, listen, a set which have only one element is called a single set. So we are having a set A that's equal to inside the bracket I am having a 1, right? So it is a single set. Okay, so for example they given x such that 3 is less than x is less than 5. It means what? So less than x, less than 3 means 3 is less than x means I am having a next number 4. So x is less than 5 means I am having a 4 alone. That's why it is a single set. See, the set of all even prime number. Okay, listen, in a prime number only one number is a even, that is what 2. Okay, prime number is having a only one even number, exactly one even number, that is 2. Okay, then they mention next we are going to see about the finite set. Finite set is nothing but we have a finite numbers. I am having a finite number of my classroom. I am in 8th standard I am having a only 34 member, right? So I am having a finite number of the students. I am having only 34 students. That's a finite number. It have a particular counting. Okay, so they given for example I am having my A equal to 1, 2, 3, 4, that's 5, 6. I know starting point and end point. Okay, I know the element of the first and last. It is a finite set. Okay, if I am having a set A equal to 1, 2, 3, 4, etc. times, keep on going, it is an infinite number. For example, I am taking a natural number, whole number, integer, like that. Okay, keep on going because I don't know where it is stop. Okay, so that's why it's keep on going means that is a infinite. I know the starting and end point means it is a finite. Okay, we can see some example. Then empty set also called as a finite set. Okay, in each set having a empty set is one element. Okay, so that's why the empty is also a finite set. Okay, what they mentioned, the set of family members. We know in a particular each family having a 5 members. Okay, that's much. That is in a nuclear family, whatever it is, we have a particular members only, your family members, right? The set of all indoor and outdoor games you play. For example, you are playing the game, we are having the level this much to this much. Okay, so that's why they given a game. Then the set of curriculum subject you learn in school. So we are having a majorly we are having a 5 subject, particularly including the 4 subject. You can study up to a 9 subject. That's it. Okay, we are having a countable. We are having a final number of the subject also. For example, xa equal to x such that x is a factor of the 36. Factor of the 36 means I can divide. 36 is divided into 2 part. What that? 36 I can factor. So 4 9s are right. That 4 is 2 2s are, and that 9 is 3 3s are. I am having my factor is 1s 2 or 3 or 4 or 9. Like that only I am having the factor particularly. Okay, it's not going keep on. Okay, that's why it is a finite set. That's it. So infinite, now only we saw, right? Infinite means I don't know the end point. So they are taking a 5 table 5, 10, 15, etc. times. Then the set of all points on a number line. Number line means number lines we know the number line by using the integer plus 1, 2, 3, etc. The -1, -2, -3, etc. I am having lots of point in a number line. I don't know. And in between numbers also I am having a in between two numbers. Okay, 0 to 1 also I am having a lots of number. I don't know I didn't mention this to this. So that's why they mention a set of all points on a number line means I am having infinite number of the lines. That's why infinite set. Okay. Then cardinal number of a set. Cardinal number of the set is nothing but if I am having my set A equal to 1, 2, 3, 4, 5 means I am having how many elements? 1, 2, 3, 4, 5. So it represented n of A. N of A means number of element in my set. So that is nothing but I am having a 5 elements. So I mentioned 5. That's it. Cardinal number means number of element. Okay, number of element that is representing n of A. You should remember this because in afterwards you are going to see about the P of A also. Okay, so cardinal means n of A. Okay, means number of element in my set. In your book they given the example 1, 2, 3, 4, 5, 7, 9, 11. Okay, how many elements you have? 1, 2, 3, 4, 5, 6, 7, 8 elements. So that's why a set contain 8 elements. So n of A equal to 8 elements. That's only the mention. Okay, then we are having two sets. The similarity. Okay, little bit similar ma. Equivalent set and equal set. Equivalent set is nothing but what I am saying. It is compared to the two set. It is comparing a two sets. So I am having two sets ma. Equal to A, B, C. Okay, my set B equal to 1, 2, 3. By using the cardinality. By using the cardinality, we will tell whether it is a equivalent or not. Okay. So I am having n of A equal to 3, right? The same. My n of B also equal to 3. Whatever element it's have, but my number of elements, I am having a 1, 2, 3 elements. So my n of A equal to 3 elements. My n of B also having 1, 2, 3 elements. That's why n of B equal to 3. So my n of A equal to my n of B, both having equal to 3, right? That's why it is a cardinality. Sorry, equivalent set. Okay, equivalent means my number of element is equal to the another set. That's one dimension. Okay, what they mentioned, two finite set A and B are said to be equivalent if they contain same number of elements means n of elements, n of A or n of B, whatever it is, should be equal. Then we can say equivalent set. Okay, equal set means equal set is nothing but I am having a set A 1, 2, 3. If I am having a set B 3, 1, 2. Okay, whether I am checking 1 and 1 the same element. Okay, 2 and 2 and 3 and 3, whatever it is shuffled also, if you are having the same element is equal, 1 is also here, 1 is also here, 2 is also here, 2 is also here, 3 and 3. Okay, each and every element should be equal, then it is called as a equal element. That's it ma. Okay, then